So you know when you send me that STL file and a few days later, I give you a 3D printed part back? Do you ever stop to think, how did that come to be? During my time as this lab's 3D printing technician, I have fabricated countless prototypes, housings, test samples, brains to name a few things. So today I'd like to give you a little sneak peek behind the scenes look at my workflow and show you how that lattice came to be. Now I'm sure many of you can already name a few examples of the advantages of 3D printing. Off the top of my head, I can think of the possibility to create any kind of geometry, which has previously been limited by traditional fabrication techniques, or the assignment of multi-material properties to a single printed part. Now, leveraging this technology, we have gone on to create many fantastic things which have gone on to impact and inspire many people. So if you're ready, let's dive in. So before getting started, we have to make sure the printers are ready. This means we have enough material on stock to finish the submitted job. Every few months I need to check the inventory we have and order anything that is running low or something I might need for an upcoming request. In the case of the U-Prints and Fortus, as known as FDM printers, it's always a good idea to preheat the chamber, as that takes a little while before they come up to temperature and are able to print. Usually half an hour does it. Now that I have all my materials ready, I need to make sure we have a nice clean building environment. I make sure we have a nice clean plate and get rid of any debris that might be in the build envelope. Failing to do so could cause problems during the print. The next step is the actual processing of the STL files and converting them into a format the printer can understand. This is also known as slicing. Now occasionally I receive a file which bounces back with the error message saying unclosed geometry. What this means is there's a seam in the part which has not been properly joined with the rest of the body, and this can lead to the part not being able to be processed for printing, or the printer has to guess what it has to do, which can lead to unexpected results. Another occasional issue I experience is receiving parts that are incorrectly scaled, in which case it's always good to make sure your dimensions are correct. My advice is to check in your CAD software that your models are watertight and at the right size before exporting. So once that's all clear, we're ready to print. Now I know what you might be thinking. How do you go from something like this to this? The simple answer is with the use of the right tools. The key thing is to remove as much support as possible by hand before moving on to the next step. Sometimes, if you're lucky, you can remove everything by hand, which saves you a lot of time. If not, we have some chemical post-processing procedures to get rid of the remaining support. Now that a few hours have passed, we can remove the parts from the solution, give them a good rinse and allow to dry. What you are now left with are prints that are ready for testing, experimenting, assembling, encasing things, or whatever you need them for. Hopefully this has given you a better understanding into what goes into producing your parts. And if you ever have questions, I'm always happy to help.